Alright guys, this is day 2 of the Similarity unit. This is our first part on the block day today. If you were here for the bell work, you already did this part, so it should already be filled in by whoever is in the room at the moment. And make sure you have that copied onto your actual notes page that's been passed out. So make sure you realize that this is the symbol for similar, that little like squiggly. We talked about that during the bell work. We're going to be using that a lot in this section. So jumping down to this one, this is super important right here. That talks about basically what defines things that are similar. Okay, well their sides are not equal, they're proportional. That means it's fraction equals fraction. Their angles, however, are congruent. That means that the angles are always going to be equal. Not all equal. They may not be all 90s, but they're equal to each shape. So for example, this picture down at the bottom, angle A is congruent to angle W, but notice the sides are not equal. They're just similar. They're just proportional. And something to note, shapes are not always going to be turned the same way, so you should focus on using this. Don't use the picture. I know it's tempting. Some of you feel like, oh, I could figure out what goes where, but in reality, you're probably going to mix it up more than you get it right. So be cautious about that. And use this part that I boxed in. So it says A is the first one, W is the first one there, that's why A is congruent to W. And then we've got all of our sides matched up here, and in fact they do have the same scale factor. If I plugged in the numbers, AB is 15 over WX, which is 5. If I did it for all of them, I'd get 3 when I divided all of them out. So that's what they're kind of showing. And then finally you've got that they're similar. So that's a really good slide to include with all of the different pieces kind of already filled out for you. So we're going to actually do this one now. Some of you might already be able to kind of zoom through it and figure it out, but we'll also work through it together. So first letter in here is N. First letter in this group is U. Again, I don't want to use the picture. It's easy to mess that up. So I'm going to make a side for angles and say angle N is congruent to angle U. Next letter up is P, and that's congruent to V. And actually I should probably mark it in the picture too. So N and U are congruent. So P and V are next. So I'm going to put angle P is congruent to angle V, and then make those double. And then just go right down the line. Q with S, angle Q congruent to angle S. And yes, you do have to have the angle symbol, you have to have the congruent symbol, otherwise you're not stating it correctly. So 1, 2, 3, 1, 2, 3. And then last but not least, that leaves R congruent to T. And then we've got 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that part I think is the easier part. That's what it's asking for you to do right here. List the pairs of congruent angles. And now you have to write out a proportion that relates all of the sides. Okay, if there's 4 sides, you need 4 fractions. Now remember our scale factor rule, new over original. We're going to use that same process here, even though we're not finding scale factor. So if I look at my letters here, I need to match those up. I've got NP, that's this side right here, should match with UV, based on the letters I already figured out. Okay, go ahead and pause here, see if you can figure it out on your own. Hopefully you can fill in the rest of the blanks by using the letters that we have off to the side here. It's kind of like a little code for your shape. So pause here, push play when you're ready, and you can finish up the rest. PQ goes with VS. QR goes with ST. Oops, I should put that here. QR, ST. And RN, make sure you're following this, goes with TU. RN, TU. Okay, so that's what it's asking for that. We listed all the pairs of congruent angles, and we've written a proportion that relates all the sides. So make sure you have that copied. Make sure you understand how we use that setup up at the top. And then we're going to kind of put this off to the side for a second and do the picture project that we asked you to bring in. If you checked your email last night, you were supposed to bring in a picture of yourself next to something tall. Okay, so I'll scroll down to that one. Okay, so there's your chart, and my picture's down at the bottom. Okay. So you can pause here and work on that, and then when you're ready, you can go back to the actual lesson. All right, so hopefully you did the picture project. I'm going to go back to the examples now. Hopefully you did that as a group. If not, that's okay. So example number 2, it says, Kuma wants to use a rectangular desktop of her dog's photo, but needs to resize it. The original picture was 8 by 10. Her options for resizing are 12 by 14 or 12 by 15. Which one keeps it similar? And explain. So we just did this at my house, actually. My husband and I just put up all of our wedding photos, and we had a hard time matching some of the dimensions at times because some frames are a little weird that were given to us, or some of the pictures just didn't get bigger to a correct proportion. So this is pretty applicable for stuff like that. Remember, your formula is new over old. And in this case, it's new length over old length equals new width over old width. That's kind of our setup for that. This is your old. These are your 2 new ones that you're checking. So let's set those up. So in this one, we'll start with A. The length is 14. The one in the old one is 10. The width in the new one is 12, the old one is 8. Now there's more than one way you can solve this. Hopefully you've already recognized a couple ways. One of them, which I think is the easiest, is just simply dividing. So if I do 14 divided by 10, I get 1.4. If I do 12 divided by 8, I get 1.5. Okay? Well, the problem is those are supposed to be the same numbers because really that's the scale factor. So if they're not the same, not similar, can't work. The other way you could have done it is to do cross multiplying. We've talked about that a lot the last couple days. So if I circle those, 12 times 10 is 120. 14 times 8 is 112, I believe. And again, not equal. Okay, so scale factors not the same, so it's not similar. Go ahead and see if you can do the second example. Maybe you can come up with that on your own. It might work, it might not. Maybe both of them are bad, but see if you can figure it out yourself. And then when you're ready, go ahead and push play to see the answer for that. All right, so new over old again. New length is 15. Old length is 10. New width is 12, old width is 8. I'm going to use the dividing way because I like that a little bit better. 15 divided by 10 is 1.5. 12 divided by 8 is also 1.5. So these are similar. Their scale factors are, in fact, the same, which is good. That's what we wanted. Okay? So make sure you understand where we got the numbers from. Ask questions if you need to. And then we'll move on to the final example for this section for today. All right, so last example we're going to do. This one, they ask you for a couple of things. Okay, so you have a few things you have to solve. It's saying determine whether the triangles are similar. So I'm going to put a 1 there for that. If so, write a similarity statement. I'm going to put yes or no, because we're determining if it's similar. I need a statement here, so something similar to something. And then 3, I'm looking for scale factor. Okay? So if I'm doing all those things, I got to be aware of that. Okay, well, how do I prove if things are similar? Well, that means I need to know if their scale factors are the same. That's what we were just doing in the last one. Now, this one doesn't tell you what angles match with which, but you can use the picture to help you figure it out. If you look at N, that matches with R because they both have these single arches. And then we've got some double arches here. Well, the side that's in between those two things is right there. So let's set up our fractions like we did last time. You need three sides, 3 fractions. We're going to call this one new, this one old. So we're going to put 10 over 12.5. Hopefully you guys can figure out what the rest of them are. But I will also fill them in. We've got double arch and nothing. Double arch and nothing. So that's 9.2 to 11.5. And then we have those ones. So 12, 15. So cross multiplying, really not a good option for this one because there's too many angles, or not angles, I'm sorry, sides. So I would divide all of them, okay? Now I've actually already done all of the dividing, so I know what the fractions are supposed to be. So I'm just going to write what they should be, but you should try and calculate it on your own as well. Remember, it's top divided by bottom. If you do it correctly, they all come out to 0.8. So that actually tells us that, yes, it's similar. Similarity statement means actually write out the pieces that match together. So triangle, I'm going to go with N, Q, P, and I got to match my letters. So N goes with R, Q goes with S, and T goes with P. That's my similarity statement. And I already did all the work for scale factor. It's 0.8. New divided by old, we just did all those fractions. That's the scale factor. Okay. Feel free to rewind or pause or whatever you need to do to go get caught up on notes. The homework is number 2 and number 3 on the back of this page. I know there's not actually numbers there, but it's the middle 2 sections. We're going to work on the more algebra type ones tomorrow or Thursday, depending on what day of class.